It's clear that nuclear research has had a huge impact on our world, making our lives better in so many ways. Nuclear technology has a lot of different uses. It's a key part of medical diagnostics and treatments, and it also generates electricity that powers homes and businesses all over the world. On top of all that, nuclear research has been a key driver in advancing scientific knowledge, leading to some pretty groundbreaking discoveries in fields like particle physics and material science. So it's fair to say that nuclear research has been a huge benefit to our planet. One of the most valuable tools in the field of nuclear research is CERN. As the world's largest particle physics laboratory, CERN has helped make some of the most significant discoveries in our understanding of the universe. We've heard recently that scientists at CERN have opened a portal and something has come through it. Join us as we take a closer look at everything you need to know about CERN in this intriguing portal situation. We'll explore what it might mean for the future of humanity. So, what is CERN all about? CERN is the European Organization for Nuclear Research, which is commonly known by its French acronym. It's a particle physics laboratory situated just outside of Geneva, Switzerland. CERN was set up in 1954 as one of the first joint projects between European countries after the war. The idea was to keep Europe's top scientists in the continent and stop them moving to the US. Today, CERN is the biggest particle physics laboratory in the world and is a really valuable hub for research in lots of different areas, including particle physics, nuclear physics, and cosmology. This is no small achievement. Each year, experts from over 100 countries come to CERN, drawn by its cutting-edge facilities and advanced instruments. Right now, more than 10,000 scientists are working hard to solve the mysteries of our universe, looking into what it's made of and the rules that govern how it behaves. CERN still has some of the most cutting-edge scientific instruments out there, which let researchers make some pretty amazing discoveries. By studying particles at the atomic level, scientists can learn more about the basic properties of matter and energy in our universe. At CERN, scientists use these advanced instruments to run experiments that try to answer some of the most basic questions about the universe and how it all began. These questions range from understanding the structure and properties of matter to looking into our understanding of subatomic particles. CERN is the perfect place for scientists to explore the unknown and uncover new truths about our cosmos. The data gathered from these experiments has given researchers a deeper understanding of the fundamental properties of matter and energy. This has enabled them to answer some of the most important questions about how the universe was created and how it operates. The research that has come out of this so far has played a big part in helping us understand particle physics and cosmology better. It's constantly pushing the boundaries of what we know, and it's hard to imagine that just a few decades ago, we were at the same point. At its core, CERN is an ever-changing entity that is always pushing the boundaries of science and technology. It's a great example of what can be achieved when scientists from all over the world work together. Its research will continue to shape our understanding of the universe for years to come. This institution is a huge achievement in science and technology, a place where experts from across the globe can come together to tackle questions that have perplexed humanity since ancient times. By unraveling these mysteries, CERN has significantly advanced our comprehension of the universe, bringing us closer to the ultimate truths of our existence. So, how does CERN actually work? In a nutshell, CERN is an interdisciplinary scientific research laboratory that provides scientists with top-notch facilities. The accelerators are designed to propel particles to a significant fraction of the speed of light, while the sophisticated detectors function like electronic eyes, allowing researchers to observe these particles in remarkable detail. The proton synchrotron, the oldest accelerator at CERN, was built in the 1950s and was at the time the most powerful accelerator on Earth. By using the proton synchrotron, scientists were able to look into the structure of matter and make some pretty amazing discoveries, including identifying several new particles. This initial success was later surpassed by the super proton synchrotron, which contributed to CERN's first Nobel Prize win in the 1980s. Eventually, the Large Hadron Collider was built in 1989 and was CERN's main research tool until 2000. This huge machine, which is 27 kilometers long and weighs over 23,000 tons, was capable of producing the highest energy beams ever made at the time. Since then, CERN has developed even larger and more advanced accelerators, including the Large Hadron Collider, LHC, which can accelerate particles to speeds approaching that of light. As you can see, each part of CERN works together seamlessly, creating what can only be described as a scientific miracle. This collaboration lets us explore areas of knowledge that would otherwise remain unknown without the dedicated research conducted at CERN. Now let's take a look at some of the most groundbreaking discoveries made at CERN. First, we need to talk about the LHC, which is mainly used to look for particles that the standard model of particle physics predicts. This includes the infamous Higgs boson, along with a whole host of other theoretical particles. The accelerator has already made some pretty significant discoveries, like confirming the existence of dark matter and showing that certain properties can be explained by supersymmetry. Building a machine of this size and complexity requires a lot of careful work to make sure everything is aligned and working properly. The Large Hadron Collider is the world's largest and most powerful particle accelerator. To get the best performance, it's kept at a very cold temperature of just 1.9 Kelvin, which is about negative 271.3 degrees Celsius. That's even colder than outer space. The cryogenic cooling system keeps the temperature down to freezing point, which is essential for the superconducting electromagnets to work properly. These propel the proton beams around the 27-kilometer loop that's 100 meters underground. If these conditions aren't met, the whole acceleration process could malfunction or, in the worst case, lead to an explosion, which would be catastrophic. The accelerator works by sending proton beams moving in opposite directions at an incredible 11,000 times per second, which creates a huge amount of energy and produces a whole range of subatomic particles, including the Higgs boson. To capture all that data from the collisions, a set of huge detectors process some of the 40 million collisions that happen every second. This incredible power and speed help us understand more about how the universe works and reveal new insights into its fundamental processes. This technology lets scientists observe events at the molecular level in our universe. This amazing technology has helped scientists make huge leaps forward in particle physics, opening the door to all sorts of new research possibilities. The LHC lets researchers look at particles at levels of energy we've never seen before, which could help us understand some of the universe's biggest mysteries. It's still an important tool for learning more about our cosmos, which is full of things we don't know about yet. The team at CERN is committed to finding out more about these unknowns. The Large Hadron Collider is a fantastic engineering achievement and a great example of what we can achieve when we use science and technology to unlock the secrets of the universe. The LHC operates at peak efficiency thanks to its extremely cold temperature, which allows us to make significant progress in understanding the universe around us. There are lots of things that make this machine special. The LHC and the standard model of particle physics go hand in hand. The LHC has been fully operational since 2008. It was designed to rigorously test the standard model of particle physics, which is a well-known theory from the 1970s. This theory seeks to explain interactions among 17 elementary particles and the three fundamental forces within our universe. These are electromagnetism, the strong nuclear force, and the weak nuclear force. Gravity is the fourth force. By smashing particles together and looking at what's left, scientists can prove or disprove the standard model. The LHC has already made lots of amazing discoveries, including the search for the Higgs boson, a particle that gives mass to other particles, which was finally found in 2012. Since then, the LHC has been used to look for other particles that might help us understand our universe better, and what's often called dark matter. Even though we know a lot about Earth and the universe, there are still lots of questions that we don't have the answers to, and that's what CERN is excited to find out. The standard model had long predicted the existence of a previously unseen elementary particle, known as the Higgs boson. After 4 decades of searching, scientists finally found it using the LHC on July 4, 2012. This was a huge win for those who believe in the standard model, but the theory still has a few loose ends. For example, we still don't know much about dark matter, the abundance of antimatter in the universe, or the origins of mass. We'll come back to the Higgs boson later on for a more detailed chat, but for now, it's important to understand that the LHC is a popular tool among physicists for answering these critical questions. It produces some pretty powerful collisions that let scientists simulate what happened just after the Big Bang, study dark matter, and observe particles that haven't been identified yet. The aim of this research is to gain a deeper understanding of the universe and the fundamental laws of nature. What's more, the work done at CERN could lead to new technologies and developments in material science. This could help create powerful radiation sources, advanced medical imaging techniques, and cutting-edge quantum computing. At 4 points around the ring, two beams of protons are sent to meet. When they collide, these protons break apart into smaller particles, which are mostly highly unstable and decay almost instantly. To collect data about these extremely rare particles during their short lives, 7 huge detectors have been built around the collision zones. These detectors can be thought of as really sophisticated and supersensitive cameras that capture what happens after each proton collision, processing the information quickly to get a general picture of what's going on at the particle level. The discovery of the Higgs boson is probably the LHC's most significant achievement. This particle was the last one missing from the Standard Model, and its discovery validated half a century of theoretical work. However, even though it has been found, there is still a lot to learn about the particle. Now that we know the Higgs exists, we need to look into its properties in more detail and see how it contributes to mass in the universe. The discovery of the Higgs boson changed how we understand mass in the universe, but it also opened new research areas, especially in areas where the Standard Model falls short. One of the most significant gaps in our knowledge is about dark matter and dark energy. These invisible forces are believed to make up about 95% of the universe, yet they have remained elusive despite decades of research. The Higgs boson could be the key to understanding these forces better, as it might interact with dark matter in ways we don't fully understand yet. Researchers at CERN are looking to get to grips with how the Higgs boson behaves to find out how it affects the universe's mass and energy. There's a chance that by using the LHC to examine the Higgs further, scientists may find clues about dark matter and dark energy, which could provide some groundbreaking insights into the structure and evolution of the universe. This quest is not just theoretical, it has the potential to revolutionize our understanding of physics, from the smallest subatomic particles to the vastness of the cosmos. Beyond the Higgs, CERN's focus on supersymmetry has attracted considerable attention. Supersymmetry, SUSY, is a theory that suggests that every particle in the Standard Model has a corresponding superpartner particle with different spin properties. If true, SUSY could explain some of the universe's most perplexing mysteries, such as why gravity is so much weaker than other fundamental forces, and how dark matter fits into the puzzle. The LHC is instrumental in the search for evidence of supersymmetric particles, but so far no direct evidence has been found. Nevertheless, the research continues, and many physicists hope that the LHC will eventually provide the data needed to confirm or disprove supersymmetry, potentially leading to a new era of physics beyond the Standard Model. The portal rumors, however, fall more into the realm of speculation and misunderstanding. While CERN has been the source of many groundbreaking discoveries, there is no credible scientific evidence that the LHC or any other experiment at CERN has opened a portal to another dimension or allowed anything to pass through. The portal claims are likely to have arisen from misinterpretations of the advanced and sometimes abstract physics carried out at CERN, such as the search for extra dimensions, which is a genuine line of inquiry, but far from the dramatic portal opening often portrayed in the media or in conspiracy theories. In the realm of extra dimensions, some physicists believe that the universe may have more than the 4 dimensions we perceive: 3 spatial dimensions and time. Theories such as string theory suggest that extra dimensions could be compressed or hidden in ways that we cannot directly observe, but could still affect the behavior of particles. The LHC will be used to look for signs of these extra dimensions by observing how particles behave at high energy levels. If extra dimensions exist, they could alter the results of particle collisions in subtle but detectable ways. No definitive evidence has yet been found, but the search continues, and such a discovery would represent one of the most profound shifts in our understanding of reality. Another fascinating area of research at CERN is antimatter. Antimatter is essentially the mirror image of matter, with particles that have opposite charges but the same mass. When matter and antimatter come together, they annihilate each other in a burst of energy, raising intriguing questions about why the universe is made up of matter rather than antimatter. After the Big Bang, equal amounts of matter and antimatter should have been created, leading to their mutual destruction. But the observable universe is overwhelmingly made of matter, leaving antimatter a rare and mysterious force. CERN's antimatter factory is dedicated to studying this phenomenon by creating and trapping antimatter particles. By analyzing the behavior of antimatter, researchers hope to understand why our universe exists as it does today, an endeavor that could answer fundamental questions about the nature of existence itself. Returning to the potential societal impact of CERN's work, it's important to note that the knowledge gained from these experiments has real-world applications that go beyond theoretical physics. For example, advances in medical technology, such as proton therapy for cancer treatment, have been influenced by particle research at CERN. Proton therapy uses beams of protons, similar to those accelerated in the LHC, to precisely target and destroy cancer cells, while minimizing damage to surrounding healthy tissue. CERN has also made major contributions to computing. The World Wide Web, which revolutionized global communications, was invented at CERN in 1989 by Tim Berners-Lee. Its original purpose was to allow researchers to share information more easily, but it quickly spread far beyond CERN's laboratories to become the backbone of modern digital life. The vast amounts of data generated by CERN's experiments are also pushing the boundaries of data processing and storage technologies, driving innovations that have benefited industries far removed from particle physics. As CERN continues to push the boundaries of human knowledge, the potential for further technological advances is immense. Whether it's breakthroughs in quantum computing, energy production, or materials science, the work being done at CERN is likely to shape the future in ways we can't yet fully predict. In conclusion, CERN is a beacon of scientific progress, and its contributions to our understanding of the universe are nothing short of remarkable. From the discovery of the Higgs boson to the ongoing search for dark matter, extra dimensions, and antimatter, CERN's research continues to push the boundaries of physics. While some of the more sensational rumors, such as those about portals, are unfounded, the actual work being done at CERN is no less awe-inspiring. By probing the very foundations of the universe, CERN is helping us to answer some of humanity's oldest questions, while laying the foundations for new technologies that will shape our future. As we look to the future, it's clear that CERN's mission is far from complete. The mysteries of the universe remain vast, and the discoveries yet to be made are likely to transform our understanding of reality. Through global collaboration, relentless curiosity, and cutting-edge technology, CERN will continue to lead the way in unlocking the secrets of the cosmos.